Hello, this is Mrs. Huntley. This is Module 3 Study Guide. I'm recording this lesson so that if you were not present in class today or if you want to review further, you have a resource available to you. So if you were in class today, this is a complete and total repeat of what you heard in class. If you were not in class today, this is your final review session before the assessment tomorrow. So, number one, it says in the diagram below, triangle ABC is similar to triangle DEF. Demonstrate the figures are similar by performing a sequence of a dilation followed by a congruence that would prove these figures to be similar. And then you'll notice that my drawings don't have a DEF, and I apologize for that. When I created the study guide, I forgot to change the directions because I changed the picture out, and the directions should actually say triangle A prime, B prime, C prime. And we did talk about that in class, but in case you didn't get that change, what we're doing is we're trying to figure out how to prove by, they're telling us that they're similar. We know that they're similar, but how do I prove that this big triangle is similar to this little triangle using dilations and rigid motions as we have been learning in this module? So how do I attack this kind of a problem? If something is written in red here, these are not explaining the problems. These are directions for you. So steps for attacking this kind of problem, we're going to use corresponding sides to figure out the scale factor. We're going to deal with the size first. So we're going to shrink the shape or grow the shape according to the scale factor. And then once we have the shape the same size, they're going to be congruent, we're going to prove that congruence using a series of rigid motions. So we're going to figure out the sequence of rigid motions that will map one figure onto the other. Now the rigid motions that we learned, translation, we need to draw a vector and slide our shape along that translation. We could rotate. We need to pick a point and rotate around that point. And we need to make sure we're saying when we're going to stop. Or we can reflect. And if we reflect, we have to reflect over a line. Now this was covered in depth in both lesson 8 and lesson 9. So if you need to look back at your original notes, that's where you're going to look. So let's attack this problem. Figuring out the scale factor. I'm going to look at corresponding sides. Here's AB, and that is 1, 2, 3 units long. I can spell, just not well. Okay, here's A prime, B prime, only 1 unit. So I'm looking at this and I'm thinking 3 to 1, that's going to be a scale factor of 3, right? Well, let's think about that. A scale factor of 3 is going to grow my shape even larger. What scale factor would let me shrink this big triangle down to be the same size as the little triangle? You're right, 1/3, because remember we take the reciprocal. So my scale factor, and I'm going to write this in blue, scale factor is 1/3. Okay, how do I dilate a shape again? Again, these are just directions reminding you how to do something. So to dilate, I determine the scale factor. Check, done. Okay, I got that one. Figure out the coordinates of the pre-image or the one you are dilating. So let's take a look at this here. My x is 15, and then I go up to 3 for A. So A is at 15, 3. B is at, again, I'm coming over to 15 on the x and then up to 6. So B is at 15, 6. C is at 6, 3. So now I need to take all of those coordinates and multiply them by the scale factor. So for, I'm going to call it A sub 1. And the reason I'm calling it A sub 1 is because I have an A prime down here. I don't want to call them the same thing, or that could confuse me. So A sub 1, I've got it 15.3 here. So I can make some notes somewhere. I'm going to erase these, so you're going to want to use scratch paper if you're making the same notes I am. So 15 times 1/3. Keep in mind when you're multiplying fractions, this would be 15 times 1 over 3. So it's like 15 divided by 3 when I'm multiplying by 1/3. So 15 divided by 3 is going to be 5. And then 3 times 1 divided by 3 is going to be 1. So I'm just going to erase this. If that is confusing you, that's multiplying by fractions. You can use your calculator. You don't have to do them in your head. That's completely up to you. B sub 1 is going to be at 5, 2, and C sub 1 is going to be at 2, 1. Now, sometimes I put the coordinates right next to each other where I'd have, I might write it like A is at 15, 3, and A sub 1 is at 5, 1. However you want to show me your work is fine. I don't have a problem either way. Just make sure it's neat and I can follow it and understand it. So I'm going to draw my new shape in. A sub 1 is at 5, 1. That's going to be A sub 1. B sub 1 is at 5, 2. And C sub 1 is at 2, 1. I'm going to use a nice straight edge to connect them up. Do a little bit thinner than normal. Okay. Now I've got the shape the same size. Now I need to look at it and determine what rigid motions are going to allow me to map one to another. Now there's a lot of different options here. Just, the option that I choose is not the only option that you can do. Just make sure that one maps on top of the other. To me, the easiest thing to do is to draw the shapes or to get the shapes close together using a vector. So I would probably draw a vector from A to A prime. And if I do that, my shape is going to end up right here. That's my intermittent move, or where it's going to end up. Now from this point, I can see that it's just pointing in the wrong direction. I need to reflect over AB. So the way I would write this up, the way that I would answer this question, first of all, I would draw exactly that. But I would say, so I'm going to do this in blue. Blue, I'm going to use blue for like my answers, and the red are like directions for you, okay? So I'm going to type in blue, I hope. Here we go, type in blue. So the first thing I did, I dilated triangle ABC by R equals 1/3. The second thing I did, I translated triangle A sub 1, we'll go A, B, C, and then let me see if I can do a sub 1 here. There we go. So I probably should have a sub 1 on all of those. Let me back up and do that. I'll do it right. Oops. See? Okay. Okay, so I dilated A sub 1, B sub 1, C sub 1 along vector A sub 1 A prime. And then finally, the third thing I did is I reflected over line AB. Oh, A prime, B prime. Okay, so I'm just going to add a few things here to make sure that my notation is correct. So the vector should have a little arrow on top of it, pretend that's blue, and then this should have a little line over the top of it because it's a line segment AB that you're reflecting over. So this drawing and this description is what you need, and show me your work. So all of this stuff in red, you don't have to show me. So I don't really want to see directions where you say, I took 15 and multiplied by 1/3, and then I took 3 and multiplied by 1/3. I don't need that specific detail. What I need is what you did. You dilated triangle ABC by your scale factor of R equals 1/3. Then you translated your triangle A prime B, or A sub 1, B sub 1, C sub 1 along vector A sub 1, A prime, that vector right there. And then you reflect it over line AB. Remember, you rotate around a point, You reflect over a line, you translate along a vector, or you tell me the number of units that you're translating. Okay, well that was a long time to go over this one problem. Hopefully the other ones won't take quite as long. Next one. How do I attack this kind of problem? Determine if the two figures are similar. Present an informal argument to present as to why they are or are not similar. So how are we going to do this? We're going to set up a proportion with the corresponding sides to see if the proportion is equal or if the scale factor is the same from each side. So what do I have here? I've got two rectangles. I've got a little rectangle. I have a bigger rectangle. So what are corresponding sides? On the little rectangle, I have a shorter side. It's TU. On the big rectangle, I have a shorter side. It's YZ. On the little rectangle, I have a longer side. That's TW. And on the big rectangle, I have a longer side, and that's WZ. So now I'm going to set up a proportion for the lengths of those sides to see if they are in fact equal or not equal. So I'm going to get a pen and figure out the unit length. So from Y to Z, I've got 1, 2, 3, 4. 4 units. From T to U, I've got 1, 2, 3 units. Now, I could set up the proportion of those sides as either 4 over 3 or 3 over 4. What I have to make sure of is that I'm consistent. If I put the big shape on top, I've got to make sure when I'm checking the next ratio that I also have the big shape on top. So, or the big shape on the bottom. I tend to put the little shape, well, if there's a prime sign, I put the prime on top, the one without a prime on the bottom. Since there's no prime sign here, I'm just going to put the little one on top, so 3 over 4. I'm going to see if that is equal to the ratio of the longer sides. So the little triangle, the longer side is 1, 2, 3, 4, 5 units. That one's going to go on top. And then the longer side of the big rectangle is 1, 2, 3, 4, 5, 6, 7 units. So I need to use my calculator. 3/4, I know off the top of my head, 0.75 when I do that division. And 5/7, 5 divided by 7, is going to be 0.71. So they are not equal, therefore they are not similar. So presenting an informal argument, I would say similar triangles have the same scale factor for all sides. They are proportional. These rectangles do not have the same scale factor. Therefore, they are not similar. That would be a perfect answer. Okay? I'm telling you my argument. If they were similar, they would have the same scale factor. They don't have the same scale factor, therefore they are not similar. They're not proportional. I'm going to do the same thing with these triangles. Corresponding sides. Check the scale factor. So I'm going to just highlight the corresponding sides. This is a little bit easier because we do have a prime. So I've got AB here. That's going to correspond with A prime, B prime here. Then I have BC here, and that's going to correspond with B prime, C prime. I'm picking the flat edges, the ones that you can actually count the units on, because that diagonal where it goes across partial units like here, I can't count that. That's not 1 unit there. I don't know what that is. That might be a little bit more than a unit, might be a little bit less, and that's actually what we're going to be learning about in the next section of what we're going to be studying. So from A to B, I've got 2 units. From A prime to B prime, I've got 1, 2, 3, 4, 5, 6 units. And so I'm going to set up my proportion. This one has a prime, so I'm going to say AB prime over AB. Plug in what I know. AB prime is 6, AB is 2. Compare it to the other side. Let's see, BC prime over BC. BC prime, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 units. And BC is 1, 2, 3, 3 units. So it'll be 9 divided by 3. 6 divided by 2 is 3. 9 divided by 3 is 3. So my informal argument here is going to be the triangles are similar because the scale factor of the corresponding sides is the same. The triangles are proportional and they are similar because that because is hugely important, guys. Don't just say the triangles are similar or yes, because how do you know? The scale factor of the corresponding sides is the same. Show me your work and you will get all of the points. Okay, the next one. Determine if the two figures are similar. Present an informal argument as to why they are or are not similar. So I've got the measure of angle B is 88. I don't know the measure of angle B prime, so I can't check that. The measure of angle C is 48. The measure of angle C prime is also 48, so I know that one's equal. I don't know the measure of A, but I know A prime is 44. Now, some people were tempted to just take this 44 and plug it in for the A and go, well, that's the missing one. And I know that similar triangles have the same angle measures, but it's asking us to determine if the two figures are similar. It's not saying they are similar. So the first thing I have to do is use the triangle sum theorem to determine one of the missing angles. So either A or B prime. I'm going to go for A just because, I don't know, it's the one on the left and I picked that one for whatever reason. So I'm going to use the triangle sum theorem. What does that mean? The triangle sum theorem, the interior angles of a triangle are going to sum to 180 degrees. So I know one is 88. I know the other one is 48. I don't know the measure of angle A, so plus the measure of angle A is going to equal 180. I'm going to add 88 and 48. Again, use a calculator, guys. I can't tell you how often I'm grading a test and people are just making silly addition or subtraction errors. So even if you think you know it, check it in your calculator. 136 plus the measure of angle A, so you don't make silly mistakes. It's going to be 180. I'm going to subtract 136 from both sides, and I know the measure of angle A, 180 minus 136 is going to be 44 degrees. So I can put that in here, and now I can check. A is 44, A prime is also 44. C is 48, C prime is also 48. So as a result of that, I know that the measure of angle B is also going to be 88. I don't even have to do the triangle sum theorem because I know that similar triangles have corresponding angle measures that are the same. So by angle-angle criterion, I know the triangles are similar. If two angles have the same measure, the triangles are similar. I know the third one is also going to be similar. I don't have to put that in here. It's not even asking for that. It's just asking me if they're similar or not. And the only way I can tell that is by figuring out that unknown angle. Now this next problem is a little bit different. The following triangles are similar. And I think in class, I might have misread these directions, and I apologize if I did that. It says find the missing angle measurements for angle B and angle C. How do you know? So since they're telling us they are similar, what do we know about similar triangles? Similar triangles have corresponding angle measures that are the same. So I know, I'm going to just use a highlighter here, I know that angle A and A prime are going to be the same. I know that the measure of angle B and B prime are going to be the same. So I already know that B is going to be 60. And of course the measure of C and C prime are going to be the same, so I know C prime is going to be 48 degrees. Okay, again, I know this because similar triangles have congruent corresponding angles. Since angle C is 48, I know that angle C prime is also 48. Since angle B is 60, or B prime is 60, I know that angle B is also 60. So you really don't have to do the triangle sum theorem here. You could, if you do the triangle sum theorem here, you should come up with this angle measure being 60. And if you do the triangle sum theorem here, you should come up with this missing angle being 48. But again, that's a lot of calculating that you don't have to do. If you remember that similar triangles have congruent corresponding angles, you don't have to do that additional calculations. All right, moving on to the next one. Whoops, I forgot to move this out from the last time I did it. The following triangles are similar. They're telling us they're similar. Find the measurement of angle B prime. So angle B prime is here. Explain how you found your answer. So the first thing I can do is I can say they are similar, so I know angle A prime is going to be 20 degrees. I know angle C prime is going to be 92 degrees. How do I know that? Similar triangles have corresponding angles that are congruent. Now to find my answer for angle B prime, I do have to use the triangle sum theorem because I don't know what B is, but I know two others, so I can figure out that third one. So the triangle sum theorem, let me see what I wrote here. I'm going to make sure that I wrote everything. Similar triangles have congruent corresponding angles. Okay, that was the first step. I filled them in. To find the missing angle, use the triangle sum theorem. So 20 plus 92 plus the measure of angle B prime is going to equal 180. 20 plus 92, use your calculator, is going to be 112. Yeah, I said use your calculator, and then I just did that in my head really quick. Yes, it is 112. Okay. Plus the measure of angle B prime equals 180. Subtract 112. Measure of angle B prime is going to equal 68 degrees. So the measure of angle B prime equals 68 degrees. Since B prime is 68, I know that B is also going to be 68. Okay? The following triangles are similar. Find the measurement of angle Z prime. Explain how you found your answer. Okay, this is going to be the same type of problem. So since they are similar, I know angle X is 50, so X prime is also going to be 50. Angle Y is 75, so Y prime is also going to be 75. And so Z is my unknown. So similar triangles have congruent corresponding angles. That's my first step of how I know. Second step, find the missing angle, use the triangle sum theorem. So I've got 50 plus 75 plus the measure of angle Z prime equals 180. 50 plus 75, again, use your calculator. It would be 125 plus the measure of angle Z prime equals 180. Subtract 125 from both sides of the equation. And the measure of angle Z prime is going to be 55 degrees. And then, of course, I know that Z is also 55 degrees. So the measure of angle Z prime equals 55 degrees. How do I know? Right there. Make sure you are explaining how you found your answer. Now, you don't have to say, just like I was explaining before, you don't have to say, I took 50 and added 75 and added Z and then I subtracted 1. You don't have to give me that detail. This is what I'm looking for, the reasons behind it, the mathematical concepts that we've been studying. Okay, our level 4 question. Oops, I forgot to move all of this away from the last time I did the problem. So let me move this away so that we can talk through it. Just like the first problem, we are going to deal with size first and then determine the rigid motions that are going to map one onto another. You could then just figure out another sequence of rigid motions rather than grow the other triangle. There are a lot of options here. This is just like that last test where you had to give me 2 different sequences. Now, the thing that I will say is if you, well, we'll get to it. On this problem, I'm giving you the coordinates already. So you have to figure out your scale factor by comparing some corresponding sides. So the easiest one, in my opinion, is looking at P prime M prime and then PM. So P prime M prime, to get from these 2 points, I've got 1, 2, 3, 4 units. And to get from P to M, I've got 1, 2, 3, 4, 5, 6, 7, 8 units. So you might be saying, scale factor, I can tell right now 8 divided by 4 is going to be 2, which that is true. If I'm growing triangle P prime, M prime, Q prime, I would be growing it by a scale factor of 2. If I'm shrinking PMQ, I'm going to be shrinking by a scale factor of 1/2. That's where I'm going to start, I think. So I'm going to dilate triangle PQM by a scale factor of 1/2. I can't remember if I put them. So that's the first thing. Now, because I don't want to draw all over my drawing like I did before, I'm going to actually put P here. And P is at -6, 4. So P sub 1, okay. I don't know why I wrote B. P sub 1, 1/2 of -6 is -3. 1/2 of 4 is 2. This is what I was talking about on, when I was doing problem 1, because problem 1 I just did it right on the drawing. But sometimes I put them side by side like this. I don't really care, again, how you do it, just as long as you make it neat for me. Okay, M is at -14, 4. It's being given to me. So M sub 1 is going to be 1/2 of -14 is -7. 1/2 of 4 is again 2. And then Q is at -14, 18. So Q sub 1 is going to be at -7, 9. Again, if you don't know your multiplication facts right off the top of your head, you're going to want to use a calculator because you don't want a silly math mistake to be your downfall. Okay, so I'm going to draw it in. I'm actually going to switch colors here, I think, because we've got a lot of blue on this page and I want this to pop out. So I'm going to switch to green. I'm going to draw my triangle. P sub 1, -3, 1, 2, 3, and then up 2. 1, 2, right there. That's going to be my P sub 1. M sub 1 is at -7. 1, 2, 3, 4, 5, 6, 7. I hope you can see the dots that I'm drawing as I'm counting, so you don't think I'm just like counting to you. And then up 2. And then Q sub prime, I'm already counted 7, and then up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to be Q sub 1. Oh, I forgot my M. Going to use a straight edge to connect them up. Going to make it green. Okay. Now my drawing is the same size. I can use a transparency at this point, and I can figure out what rigid motions are going to get one to map on top of another one. So I am looking at this, and I know my P and my P sub 1, they've got to trade places in effect. I've got to get this to be closer to the y-axis. So I think what I'm going to do is I'm going to reflect over the y-axis. So if I do that, my drawing is going to end up over here. Why did we just not do what I wanted to do? There we go. And then M is going to be here, and then Q is going to be here. And I'm just going to put this with a dashed line, because if I reflect over Y, that's where it's going to go. Okay, that got me closer, but not quite where I want to be. At this point, I have a lot of different options. I could reflect over X, but I won't be exactly lined up. So I could reflect over X and then translate 1 unit to the right. I think that's the way we did it when I was after school yesterday helping some students. I could actually label this like P sub 2, Q sub 2, and m sub 2 so that I know that I actually moved it there. And then I could draw a vector. Oops, I just flipped these. Sorry. I hope you didn't copy me because I just flipped these accidentally. So this should be p sub 2. This should be m sub 2. I could draw a vector from m sub 2 to m prime, and then I could reflect over p prime m prime. That would be a good option. So let me go ahead and write that up. I'm going to have to change what I had because I think that's a better choice. So I reflected over the x-axis. That is indeed what I did. And then the rest of this I did not do. So let me get rid of that. So my third move was translate along vector m sub 2. I'll add the 2 in, m prime. Let me get that m on the same line. I want my vector on the same line. There we go. And then the fourth thing I did was I reflected over line p prime m prime. Okay. So we're just going to draw a couple more things in to make sure. Whoops, that's not what I wanted. Yeah, I do. I want thin. So here's my vector. Come on now. Why are you not being a pen? There we go. And this is m sub 2, and then reflected over line p m. And that would get one to map on top of the other. Now, your other options for doing this a second time, they're infinite. I would suggest doing the dilation just once, because I can use this same dilation and just do a different series of rigid motions. The other one that I came up with yesterday that struck me as like, why didn't I see this before? Because it's an easy peasy one, is draw a vector from p sub 1 to p prime, and then rotate around p prime until q maps to q prime. It's going to be 180 degrees once you draw them close together. Now you could put a point at the origin, but on this particular one, if you rotate around the origin, it's not going to map up exactly correct. It's going to be 1 unit off, and I didn't recognize that when I wrote the review, because I actually wrote this review. So I apologize for that. When I was placing this triangle, I had actually intended to have it 1 unit over to the left, but I didn't, and I didn't actually do the review until after I had them all printed. So anyway, so the second one, my second option, because I have to have 2 different sequences on my level 4. Whoops. Let's get rid of that. I have to have 2 different sequences on my level 4. So here's my one sequence. Here's my second sequence. So I'm going to leave my dilation alone. I'm still dilating this triangle by r equals 1/2. I'm just finding a different series of rigid motions to get them close together. So I'm going to translate from p sub 1 to p prime, and then rotate around p prime until q maps to q prime. On this particular one, you do have the option of growing this little triangle by a scale factor of 2 and then moving it back. Again, the chances or the options here are, there's a ton of options. There's no way that I could record all of the different options that you have of doing here. That's what makes actually grading this somewhat of a challenge, because I have to check each and every one of yours when it comes to grading the test to see if what you came up with will actually work. On this particular one, I do have enough space here to grow the little triangle by a scale factor of 2 and then move it back. You'll have to check when you have the assessment to see if that's an option for you. It may not be. The grid pattern that you have, or the coordinate grid that you have, may not be large enough to do a dilation where you're growing something. You might have to be satisfied with using the same dilation and just coming up with a different series of rigid motions. So that is it for the study guide. I hope you were in class today. I hope this has been helpful for you, and please study. Please do well on the test, and I look forward to seeing you tomorrow. Have a good night.